try it. All right, so look at the first one. So what I want to do is review what we did on, what's today? Thursday, Tuesday, whatever. Last day we were here, whatever it was. All right, so we tried to discover this. All right, so there's always if two things are similar, there's a ratio between the two, right? So let's do this first before we work this problem out. They're telling you these two shapes are similar, so they're proportional. They're giving you this side and that side right there. Okay, so first, we could figure out what the scale factor is, which just means what's the ratio between the two by putting 5 over 25, which is 1/5. Okay, so let's write that down first. So the ratio between the two is 1 to 5. Now, the other two things that we did were perimeter and area. They are still going to be proportional, but here's what we need to remember about this. When I do perimeter, like when I add the sides up, the ratio stays the same. So if we were going to work with the perimeter of these two, we would keep 1 over 5. It wouldn't change. It would stay exactly the same. So the ratio of two sides and the ratio of the perimeters will always be the same, as long as they're similar shapes. Everybody with me so far? Now, area, think about this. Area is squared, right? So what we found out last Friday was if we want to work with area, we take the ratio of those two and we square it. Okay, so the area ratio is always whatever my original ratio was squared. So in this case, I would use 1 over 25. So everybody see where I'm getting the 1 over 25 first? So that's the ratio I can use to solve for a missing part. So in this case, if I'm setting up a ratio here, I got 1 over 25 equals. Now the next key you got to know is, in this ratio, obviously 1 is smaller than 25, right? The area they gave you was of the bigger shape. So therefore, it has to go with the bigger part of the ratio, and you're trying to find the other part. So if I cross multiply, 25 times x, 200 times 1, divide by 25, and I would have the area of the smaller triangle. Okay, so area ratio is the ratio squared. Perimeter ratio stays the same. So on the second example that they gave you, we've got 3 and 10 would be my ratio, right? But this one's working with perimeter, so it won't change. It will stay the same. I'm going to put 3 over 10 for that ratio. Okay, it told me find the perimeter of the bigger triangle. So they gave us 8 is the perimeter of the smaller one. So I'm going to put 3 over 10 equals 8 over x to solve that one. Does that make sense, everybody, why I'm putting 8 on top? It's supposed to be the smaller part, so I'm finding the bigger perimeter. Now we can cross multiply. Yep, 26 and 2/3. Mm-hmm. That would be the perimeter of the larger triangle. Okay, so what it's basically saying is since the perimeter of the smaller one was 8, to keep it in this 3 to 10 ratio, that's what it would have to be. All right, now, so today, the new thing we're going to do, we're going to work with volume, actually surface area and volume. So let me ask you this question. If I told you the area ratio was squared, do you think surface area would be any difference? It would not. Surface area works the same way because it's still area. So let me do this, okay? I'm going to take this ratio right here, this 3 and 10. So here's what we've discovered so far. SF is scale factor or original ratio or the ratio between the two sides. So if I know that ratio, the perimeter ratio does not change. Okay, everybody with me on that so far? The area ratio, if this was what I was working with, 3 and 10, the area ratio would be 9 over 100. I would take the 3 and square it and the 10 and square it. Okay? If they use the word surface area, that doesn't change anything. It's just area. It's still a 9 over 100. Okay? So area and surface area, even though there's the surface word in there, it's still area, works the same way. Now, let me ask you a question. Today, we're going to throw this in here a couple times. If we're using that same pattern, if you find the volume of something is cubed, right? So take a guess, how would we get the volume ratio if we knew the original ratio? You'd cube it. Does that make sense, everybody? The pattern stays the same. So if we're going to work in volume, I'll take this right here. It'd be a little bit harder to work that in your head maybe, but basically what I'm going to do is take the 3 times 3 times 3 and take the 100 times 100 times 100. So I would cube. Now, I'm not cubing the area one. You guys with me? It has to be the original ratio. But if I cube it, that will tell me the, that's a big number. Did I do that right? Yeah, why did I put 100 in there? Thank you. I was like, why are we getting to 1,000,000? Dawson, you got to cut that out of the film later, okay? Can you do that for me? How about that? That's a little better. Now I only got to add 3 zeros. Okay. Everybody good on that? Does that make sense? All right, do this for me. Flip to the back of this where it says number 4. So what I want to do is go through this chart with you to see if this makes sense, what we're doing. All right, so they got a chart. Okay, in this chart, we got scale factor. Okay, now they're putting surface area there, but that could just stay area. It wouldn't change anything. You guys with me on that? Surface area works the same way. And then it's got volume. So what we're going to talk about right now is if they give us one of those, how can we find the other two? Now, the easiest one is if they give us 2/3 and they say that's the scale factor. To get the surface area, we just take that and do what? Square it. So I'd have 4/9. And then the main thing you have to remember is don't do like I did over there. Write down the area one. Go back to this one. It's got to be this one here. The 2/3 has to be cubed. Okay, now you guys take a second for the next one where they give you 1/4 as a scale factor. Write down the area ratio and write down the volume ratio. Okay, so everybody going to be 1/4, 1/16, 1/64. Everybody good on that? Okay, now on all the other ones, okay, when they give you one, you're going to have to go backwards to the original ratio before you find the other one. So what I mean by that is, if this is the area one, what should I do to the 9 and the 16 to get the ratio? We're going to square root it. Okay, so we're going to take the square root of both. So I would end up taking the square root of 9 and the square root of 16 to get just the original ratio. Does that make sense, everybody? And then to get the volume ratio, now you would take that one and cube it. So 3 cubed would be 9. 4 cubed would be 64. Yeah, why am I messing that up? Struggling. And it's all on film, too. Yes, it would have to be bigger than the 9. If I was using common sense at that moment, but I was not, evidently. Because if you square and cube it, it cannot be the same number. Okay, is everybody good on the idea, the concept, other than me messing up my multiplication here? Okay, now this one, I'm going to show you this. Now, some of these you might be able to figure out in your head, but on your calculator, okay? So if they give you the volume one, you've got to go backwards to get to the original one first, all right? On your calculator, the button you're looking for, and it depends on your calculator, but it looks like a square root, but some of them have a 3 in there. Now, sometimes some calculators will only have an X in there. You got to punch in the 3. But you can use your calculator to figure out the cube root. So what you'd want to do is take 27, find the cube root button if you can, punch that in, and then hopefully, go ahead and test it to make sure it works, but you should get 3 when you punch it in. And then when you do 125, you do the cube root of that, you should get 5. All right, can everybody find it? Hey, Dawson, will you stop that now for a second?